So the last section of this course is on Lte roaming architecture. In this section, we are going to investigate how the network architecture that we have looked so far evolves to support Lte roaming, and we will take a deeper dive into the different architectures that have been proposed by the standard bodies. By the end of this section, you would have had a good overview and understanding of the different Lte roaming architectures. The first question that comes to our mind is, why do we need roaming and what it represents? So roaming is an important functionality where operators share their network with each other, with each other's subscribers. Typically, roaming happens between operators serving different areas, such as different countries, since this does not cause conflicts in the competition between the operators, and the combined large service area benefits them as well as the subscribers. So a good example would be, say you are a network operator in the US and you deliver Lte service to your subscribers, but now your subscribers also happen to visit Canada, and you want to ensure that they are able to use Lte service while they are in Canada. You would have to set up Lte roaming with an operator in Canada. So the words home and visited are used as prefixes to many of the other architectural terms to describe where the subscriber originates from and where it roams to, respectively. So when you look at the architectures in the standard documents, you would come across these two terms quite frequently. One is called home and the other one is visited. So home refers to the home network of a subscriber that is currently roaming in a network that is other than its home network. And the network that the subscriber is roaming on to is called the visited network. So just try to understand home versus visited. Home is where the subscriber belongs, and visited network is where the subscriber is trying to get Lte service. So in the previous example, we were talking a subscriber from the US going to Canada. So the home network would be the US network, and the visited network would be the network in Canada. 3GPP and system architecture evolution specifications define which interfaces can be used between operators and what additional considerations are needed if an operator boundary is crossed. In addition to the connectivity between the networks, roaming requires that operators agree on many things at service level. Example, what services are available, how they are realized, and how accounting and charging is handled. This agreement is called the roaming agreement, and it can be made directly between the operators or through a broker, which can be an IPX, which is called an IP exchange. The 3GPP specifications do not cover these items, and operators using 3GPP technologies discuss roaming-related general questions in a private forum called GSM Association, also known as GSMA, which has published recommendations to cover these additional requirements. So, in a sense, when you are working with roaming operators, you have to negotiate what services your home subscribers would be using in the roaming network, and you want to, as part of your roaming agreement, first you have to define what services would be available to them. Second, you would have to also come up with how the billing and accounting would work. So would it be like a flat rate billing, or would it be volume based billing, All those things need to be worked out as part of your roaming agreement. And also QoS, quality of service, would also need to be worked out as part of your roaming agreement, whether you want your subscribers to get best effort versus guaranteed QoS service. So those are things, some of the things that constitute the roaming agreement. And the roaming agreement is not defined by 3GPP. Instead, it's something that two operators or more operators or a party of operators work together and agree to. And GSMA is a body that specifies a lot of the rules around Lte roaming. So GSMA regularly publishes some guidelines on their website, and this happens to be the link to this particular document. This document is called the IR88, as the title suggests. It is aptly named Lte and EPC Roaming Guidelines. This is again a document that is published by GSMA and lays down the groundwork for implementing roaming between operators. This version happens to be released on 7th of June in 2018. But if you are really interested in how Lte roaming works and what the requirements and guidelines are, I would recommend you go through this document in detail. And this is a pretty exhaustive document. It goes down to a lot of detail around Lte roaming and its implementation. Now, before we look into the architecture of Lte roaming and how it changes when we want to do roaming between operators, let's revisit this architecture that we have looked at in the previous sections. And this looks familiar for the most part. You have the EU TRAN here, you have the EPC here, and within the EPC you have the mobility management entity, you have the home subscription server, you have the serving gateway, and you have the packet gateway that's connected through a firewall out to the external network. I would like to bring your attention to this new network element that we have introduced here, which is called the PCRF. And PCRF stands for Policy Charging and Rate Function. This is a new network element that is needed for Lte roaming, and GSMA prefers that it be included as part of the Lte roaming setup, especially if you are doing certain services where those services require setting up of either guaranteed bitrate bearers or require dynamic QoS, so changing QoS of your bearers on the fly. This PCRF interfaces with the HSS using an interface called SP. This interface is used to retrieve all the profile information from the HSS, and this PCRF also interfaces with the P gateway via the GX interface. So that's the PCRF for you. Some more background on PCRF. The policy and charging rules function is responsible for policy control, decision making, as well as for controlling the flow-based charging functionalities in the PCEF, which stands for Policy Control Enforcement Function, which resides in the P gateway. So if you look at the 3GPP documents, the policy control and charging framework has been defined in those documents, and they have distributed the responsibilities of the PCC framework between the PCRF and the P gateway. So PCRF is where all the policies are, and PCEF, which is the enforcement function, is actually part of the P gateway, where the actual enforcement of the policies happens. The PCRF provides the QoS authorization that decides how a certain data flow will be treated in the enforcement function and ensures that this is in accordance with the user's subscription profile. So if you remember from our discussion around bearers, we had seen that you have bearers which are virtual connections between a UE and the LTE network. Those bearers have a given QCI class, and within each bearer you can have multiple service data flows. Now, and those service data flows can be treated differently depending on their properties. So the PCRF provides QoS authorization for those service data flows and gives the guidelines to the enforcement function on how to treat those service data flows individually. And so that's one key aspect of the PCRF. PCRF also provides service management and control of the 4G service. It is capable of dynamically managing and controlling data sessions. It enables new business models. It also has the ability to make it easy for other devices out of the 3GPP network, like Wi-Fi or fixed broadband devices, to access the 4G LTE network. So there is a new framework called IMS framework, IP Multimedia System. And for the purpose of this discussion, just keep in mind that that IP multimedia system can work with the PCRF that is part of the LTE EPC, so that some of the non-LTE devices can access the LTE network. So PCRF is mostly the policy engine, and the enforcement engine is part of the P gateway. Okay, now hopefully you have a better understanding of how PCRF fits in to the LTE network architecture that we have looked so far, and we'll in the next section we will talk about how it's involved in the Lte roaming architecture. So if you were to go through the IR88 document that I had mentioned a couple of slides back, you will notice that GSMA has proposed two kinds of architectures for Lte roaming. The first architecture that we are going to look at is called a home routed architecture. So on this diagram here, we have the EU-TRAN, which is the radio access network. That radio access network is connected to the MME, and the MME is connected to the serving gateway. Now, there is a red dotted line here which denotes the demarcation between a visited network versus a home network. So HPMN is the home network and VPMN is the visited network. So on the visited network side, you have the EU-TRAN connected to the MME, the MME connected to the SGW, and the MME on the visited side connects to the HSS on the home network side via the S6A interface, which is a diameter interface that we have looked at in the previous sections. The S gateway of the visited network connects to the packet gateway of the home network via the S8 interface, and the P gateway of the home network is connected to the home PCRF and the offline and online charging functions, which are just billing platforms for the most part. And the PCRF is connected to some application functions within the home network. So um, one important thing that I would like to mention is that everything below this red line is the visited network, and everything above this red line is part of the home network. There is a legend here where the solid black line denotes GTP traffic. So you will have GTP traffic between the UTRAN and the S gateway, S gateway to the P gateway. Um, and then you have diameter traffic across the HSS and the MME. And then you have some IP traffic going here between the P gateway and the services, and this is your roaming interface. So now how does this fit into the roaming architecture, you may ask? So you may have a UE that is visiting a roaming operator, say it's in this region, and it connects to the EU-TRAN in the roaming operator's network, and at that point the LTE attach. If you remember the call flow in the previous sections, the first thing that happens is authentication. So in order to authenticate a visiting subscriber, the MME works with the home HSS, retrieves all the authentication information and authenticates the subscriber. After that, the MME sends a create session response, create session request to the S gateway. Now, since this is a roaming subscriber, the create session request from the visited SGW, rather than going to the visited P gateway, it actually goes to the home P gateway, and the home P gateway sets up the IP address allocation and also the bearers. Once the proxy binding process is complete, the create session response is sent back from the P gateway to the SGW, and that create session response is forwarded off to the MME. The MME sends initial context setup to the EU-TRAN. The EU-TRAN sends a RRC reconfiguration message, and then there's a reconfig complete from the UE side, and the default bearer for this subscriber is set up. So the key point to note here is that in the home routed architecture, the UE actually uses its home network's P gateway and all the functions and services of the home network, and also like the PCRF is used of the home network, and not the visited network that may be here. One thing also to note is that all the user plane traffic of this subscriber that's roaming here is sent to its home network. So now the other possibility that may come to your mind logically is having a local breakout kind of architecture, where in this what happens is you still have the home network here, and you have the home HSS. You have the visited network, below the red line, the roaming interface. You have the EU-TRAN of the roaming. You have the MME, which is of the roaming partner. You have the S gateway, serving gateway. You also have the P gateway of the roamer, of the roaming network. You have the PCRF V. If you prefix PCRF with V just means a visiting PCRF. And you have some services here, which can be your IMS services and some application function services. So if you compare this with the previous, when a UE is attaching to the EU-TRAN here, the MME works with the home HSS to authenticate. Once the authentication is successful, the MME reaches out to the visiting SGW with a create session request. Now, this is where it gets different from the previous scenario. Now, rather than the S serving gateway sending that create session request to the home P gateway, it instead sends it to the visited P gateway, to its own P gateway in a sense, and sets up all the bearers for that given subscriber that is trying to get LTE service, the roaming subscriber. So just to recap, the important difference here is in the home routed, you are sending all traffic back to the home network of the subscriber, whereas in a local breakout, you are taking care of all that traffic locally. And that's why it's called local breakout, because you are handling the traffic locally. Now, there are pros and cons of each of these architectures, and what you choose really depends on what the use case is. And there are operators around the world that have a mix of these deployments. So, to give you one example where you may want to lean towards one architecture versus the other, is let's talk about voice over LTE. So, as we know, voice over LTE is a service where we deliver voice traffic over LTE. Now, we all know that voice has strict latency requirements, and you, in order to obey the QoS, it may be a little challenging if you were to send all the voice traffic to the network of the home, to the home network for every single call, every single packet, versus in a local breakout where you are able to handle all the traffic locally. So the round trip times of packets may be substantially less in a local breakout compared to a home routing where you are sending every traffic packet all the way back. So in that case of in case of a VoLTE deployment, you may want to lean more towards a local breakout versus a home routing. But there are challenges with local breakout as well. And there are specific challenges around APNs, access point names. But from a QoS point of view, the local breakout makes a little more sense. Now, you may have another use case where you are just doing LTE data and not voice over LTE. In that case, latency is probably not that big of a deal, and you would want to bring back all the traffic to your home network. So in that case, to either save on cost or just get a better control on the subscriber experience, home routing or home routed based architecture may make a little more sense. So again, the which architecture you decide to go with is a function of the use case and the business case, but both architectures are specified by GSMA and are capable of offering roaming to LTE subscribers. So this concludes this course on LTE EPC. I hope that you got a good understanding of the LTE EPC architecture and the different network elements and their functions and how they work and interwork with each other. I hope you are now prepared to troubleshoot network problems in a better way, and I wish you all the best. Thank you.